Good morning. My name is Steve Maher. I'm with Risk Management Professionals, and welcome to our continuing education series on offshore facility process safety. Today we're going to be focusing on the effective creation and appropriate application of safety cases. We have some great speakers, great material. We'll be starting with Esther Brawley, moving on to Ian Sutton, Carlos Cheek, and myself. And what we're going to try to do is identify good applications, what might be coming up in the regulatory environment, and how to deal with these potentially new issues. Before we get started, just a little bit of logistics. Given the fact that this is a broadcast webinar with the ability to do interactive two-way communications, the participants in the audience will be kept on mute throughout the course of the presentations. What that'll do is that'll make sure that any cross-chatter, phones ringing, etc., don't show up on everybody's screens, and also interrupt the presentation itself. During the course of the presentations, our producer Nicole Otromba will be monitoring a chat box. If you do have any questions or have some issues that you feel need to be brought up, please feel free to make a note of that. At the end of the presentations, we'll open it up for interactive question answer. You can pose questions via the chat box. You can also pose them anonymously. Our producer, Nicole, will go ahead and just reiterate the questions. Or if you want to, you can be brought online with your audio live. Okay, so without further ado, let me tell you a little bit about what we're going to go over. We want to start with current developments in offshore facility regulation, look at accident causes and performance indicators, talk about the differences between prescriptive and performance-based safety requirements, which really form the basis for where we might be going from here for offshore facilities in U.S. waters. Proposed process safety management system regulatory models we want to talk about. Details on safety cases. Ian Sutton will be going through a lot of those. And we want to talk about good applications, what's happening currently, and how to properly address the needs of the regulatory requirements without overdoing it. We want to talk about sensible implementation of safety management system programs in general. And also, what should you be doing now? Everybody who's following this is aware that there's a lot of regulatory developments on the near horizon, but it's not clear exactly where a lot of them are going. What should you be doing? Should you be just sitting back and waiting, or are there certain things that are productive to do and also conducive towards the workplace safety and making sure your employees have a safe work environment? Also, I want to talk about available resources that you've got within your company, and then open up for question and answer. What we're trying to do is build on things that we've done before. In our last webinar, I'm not going to go through this in detail, but we did go over a lot of the different safety management system regulations, what's out there and what's been done historically. What we want to do is today is build on that and also address safety cases. And a lot's been happening lately too. Since our last offshore facilities process safety webinar on July 22nd, the Macondo well was brought under control with a static kill, and there are still efforts being taken to do a more permanent fix, but a lot of the releases were ended in early August. The Bureau of Ocean and Energy Management and Regulatory Enforcement public forums have been conducted in New Orleans, Mobile, Pensacola, Santa Barbara, Anchorage, Houston, Biloxi, and Lafayette. Those have been providing a public forum for looking at these safety regulations. There's also been another fire that's occurred in the Gulf of Mexico that's also undergoing investigation. The blowout preventer on the Macondo well was recovered and also transported to NASA for analysis. There's been a lot of, at these public forums, there's been a lot of presentations by other regulatory agencies and also consultants about the sort of things that they would recommend for the regulatory developments in the United States. And also, just last week, BP and the Department of Interior released some initial investigative reports on the Deepwater Horizon accident and the Macondo well release. So lots been happening, and a lot of it's moving towards a spectrum of regulatory requirements that have a full range of safety management systems. And again, today we want to focus on safety cases. To get started with our discussion, and also to talk a little bit about accident causes and the developments of safety cases themselves. I'd like to introduce Esther Brawley. She's a senior engineer with Risk Management Professionals. She received her Bachelor of Science in Mechanical Engineering from California Maritime Academy and sailed as a marine engineer in commercial ships. She's played a key role in over 120 facilities of all sizes with training, development, and management of safety management systems to address all these different overlapping regulatory requirements. She's a trained and experienced HAZOP and LOPA facilitator. We'll be talking more about that shortly. And in addition to this kind of support, she's participated in major process facility, mostly refineries and offshore facilities, expansion projects during the front-end engineering design and detailed EPC phases. So let me introduce Esther. There you go. Okay, sure.
Okay, so what I'm going to do is just kind of do an introduction to the technical content. So basically, our presentation is going to highlight safety cases, what they are, and how you do a safety case, what the content is. I want to give you a little bit of introduction as to how we got to there. All right, so first off, both prescriptive-based regulations and performance-based regulations are trying to achieve the same goal, and that is basically process safety incidents are rarely caused by a single catastrophic failure. It's multiple barriers being compromised. And then I have two very common diagrams. You have the Swiss cheese model and then the spinning disc model. And basically, it's these holes or weaknesses. They could be human error, component failures, etc. And they all come together, and then we have a catastrophic accident. Now, most catastrophic accidents had what we call performance indicators. There's leading indicators that took place beforehand and what are called lagging indicators. And this diagram is from a really good API recommended practice that talks about performance indicators and doing performance indicator auditing. The reason why we bring this up is regulations that are prescriptive-based don't really focus on the effectiveness of that regulation. They look for basically a list, a checklist, and you check off the checkbox, and yes, you have this installed, check. You have this in place, check. Did you do this? Check. And you're not really looking at the effectiveness of the program. And that's where performance-based regulations come in. Because our goal here is loss of primary containment. And these kinds of indicators, you're not going to be able to measure from typical injury reports, slip, trips, and falls, and those kind of measurements. So basically, prescriptive versus performance-based regulatory requirements. What are the definitions? This can be very confusing for people who are not involved in the process safety industry like we are. So prescriptive regulations, basically, they tell you exactly what you need to do to achieve compliance. And that's part of the problem, is that both management or facilities and regulators are just focused on achieving compliance. Let's do the bare minimum to achieve compliance. Check the box, check the box. And you're not really looking at effectiveness. Is this working? Performance, the performance of these programs. So now we go into goal-based or performance-based regulations, which are, you know what the desired outcome is. You as an organization use the best tools available to achieve that level of safety. And the pyramid there just kind of gives you an idea how that works up and down. Okay, so why are we moving in this direction? Basically for a couple of reasons. The minute you come out with a prescriptive-based regulation, industry is moving at a much faster pace than regulators can. It's very time-consuming. You have to go through public review periods. It can be very political to come up with a regulatory requirement. So pretty much a couple of years after you come out with a regulatory requirement, there's new standards, new technology, new innovation that makes that prescriptive requirement obsolete. And if someone is just focused on compliance, just achieving compliance to this prescriptive-based regulation, they might not be utilizing those tools. So the benefits of performance-based regulation is you adopt the current best practices. It is more cost-effective for companies. They don't have to reinvent the wheel. They don't have to make their organization fit within these prescriptive requirements. They can adapt, they can evolve, and they can make it work with their organization. And then obviously you can permit the use of innovative technology. Like I was saying, prescriptive requirements most of the time kind of get reduced to a checkbox type, checklist type program. Now, not to say that, I mean, a lot of my clients go above and beyond the regulations and do performance-based on their own, but we're just looking at regulatory requirements here. So performance-based requires that the company or facility demonstrate that they have managed all of the risks accordingly through a coherent and compelling safety argument or safety case. So that's where safety case comes from. All right, so I just want to give you some examples of prescriptive-based requirements. This is a great recommended practice. It's really good at giving you the bare minimum, and that's API RP 14C. And these are some examples from that recommended practice on, wellhead flow lines. These are recommended safety devices. So this would be your minimum. This is the prescriptive requirement. You can just check the box. Do I have the TSC, the SSC, the low pressure switch, the PSV, the pressure control valve, etc. Here's another example for underwater wellhead flow lines. Here's one for pressure vessels. Now, just to kind of give a very simplified example of comparing prescriptive-based to performance-based, this diagram here of a pressure vessel is a great example. So here's what the minimum requirements for 14C. Now, 14C has a lot of different requirements. It does get into a system still, but just to give this example, most facilities for newer designs, when I do a house-up study, they would have an independent low-level switch that would be closing an emergency shutdown on the liquid outlet of this vessel, and that's to prevent a gas flow-by scenario. Now, if you were just focusing on, okay, let's check the box that we have all these devices on our pressure vessel, you might miss that. But if you are looking at the latest tools available to you, such as looking at independent safeguards, using layer protection analysis, and other types of quantitative risk assessments or whatnot, you would have picked that up. Okay, so example of a performance-based requirement. Basically, it's a set of evidence. You make a case for why your system is safe. And so you present this evidence, body of evidence, and the regulators can then audit that. Now, one key thing here, though, is that, A, the people pulling this evidence together need to know what they're doing. They need to have a background in process safety management. But then also, on the flip side, the regulators need to be able to properly evaluate this evidence. And this is kind of the challenges that I think we're going to face here in the U.S. if we start going towards performance-based, is our whole regulatory system and our industry is kind of set up for some of these prescriptive-based requirements, and there's going to be some training and innovation on their part to be able to put this together. So therefore, the facility must make a safety case to justify the acceptable safety of the system. And there's a variety of goals. You always look at industry, the latest standards and guidelines. You do various hazard analysis or vulnerability assessment tools, and you have a goal-based approach to making this safety justification. So some of the regulatory paradigms that we're going to face here with this, before we go into more detail on safety cases, is you still are going to need prescriptive-based regulations. Prescriptive-based regulations are great for laying out exactly how something needs to be designed, giving a minimum design criteria, a minimum list of safety devices that need to be installed, and minimum type of safety program that needs to be in place. You're always going to need prescriptive-based. You really need them both. Another recommended reading is API RP 754. That's covering the performance indicators. Those are going to be important if we start moving into performance-based systems, because you need to start measuring these performance indicators, these leading and lagging indicators that are going to alert you to the possibility of a loss of containment. So from API RP 754, you have the identifying of leading and lagging process safety indicators so that you can drive performance improvements. Whereas prescriptive tends to, okay, we met the requirements, let's move on. Performance is always looking at the effectiveness and how this is working in your organization. And also process safety indicators need to drive process safety performance and learning. Performance-based regulatory requirements do require objectives. And that's the key if we start moving in that direction in the U.S., is we really need to make sure that these regulations are written well to properly define the objectives. One of the hurdles, like I said earlier, is the engineering performing these safety tests and analysis. They have to be competent and well-trained. It can't just be another study that they have to add to their long list of process engineering tasks. The processes used throughout need to have the life cycle needs to be effective, needs to be high quality, it needs to be based on current best practices. Now, the current best practices are always changing, and so that's why that's going to be a hurdle, because you need to have people with expertise that are constantly staying up on the latest safety standards and guidelines. And basically, another hurdle that we're going to face is that there really have not been a lot of studies on the performance-based standards. They're out there, people have been using them, but there's no really good studies that have really compared the two. This is basically the spectrum. SEMP and SEMS, that's basically a safety management system. Management of change, operating procedures, process safety management. And all of these things are tools that are going to fit in your safety case. So the safety case just actually goes above and beyond what the minimum of SEMP and SEMS is going to require. These are all the elements of SEMS and SEMS. This is just a safety management system. You have your hazard analysis, MOC, operating procedures. I think people are really familiar with this. So now, this is common in the U.S. Now we're going to jump into safety cases. So just a quick overview. Our colleague Ian is going to go into more detail on safety cases. This is just a quick overview of the history. Obviously, we had some original 1992 requirements that include things like fire risk analysis, evacuation, escape and rescue analysis. There was an update in 2005 talking about early design notification, removal of safety case resubmittal requirements, and then license fees to ensure that the operators are capable of fulfilling their legal responsibilities for safety. This diagram is also in the industry called a bow tie. This is basically typical safety case content. So, of course, you have facility description, you have your management system. What management system you have in place to implement safety, and then you have your formal safety assessment, safety critical elements, and performance standards, as low as reasonably practical, demonstration, and your fitness to operate. So now, and these are all just the tools that you will use to make your safety case. So without further ado, I'm going to introduce you to our colleague, Ian. Ian Sutton, he's a PE. He is a chemical engineer who specializes in risk assessment and process risk management, process safety management, and refining chemical and offshore oil and gas industries. He's out of Houston, so he's going to be patching in through a video here in a second. He's widely published. He's closely following the changes in process risk rules and regulations that are currently taking place in the offshore regulations. His education includes chemical engineering from Nottingham University and his master's degree in literature from the University of Houston. And for additional information on Ian, you can see www.stv07.com. So we're going to turn over to Ian.
All right, thank you for that. First, can I do a logistics check? Am I coming through? Can you hear me?
Coming through just fine, Ian.
Okay. Right. Could you go to the slide saying sections of this presentation? All right, thank you. Well, first, thank you very much. My thanks to Steve and to the people at Risk Management Professionals for inviting me to participate in this webinar. I'm in Houston, Texas, and this webinar is being organized out of Southern California. So I hope the logistics work out okay. If you see me glancing to my left, it's because I'm glancing at my paper notes. We're going to talk about safety cases. Safety cases have a reputation, well, not just a reputation, they are perceived as being a European thing, mostly North Sea offshore. I have a European accent, but that's coincidence. I've spent virtually all of my career working here in the United States, most of it in the Houston area. I've divided this presentation basically into 4 areas. There's a lot of ground to cover. Inevitably, I'm going to be moving too quickly or quickly through some of it. First area is the background to safety cases. How do we get here? The second is a structure of a typical safety case. And the word typical is important. There's no one way of doing safety cases. It's this whole non-prescriptive concept. That what works on one facility may not work on another. Then the heart of the safety case is what's called the formal safety assessment. And there's probably multiple webinars on that one. And finally, the safety case, like any safety document, has to be kept up to date. Things are always changing, and the safety case has to reflect those changes. Next slide. For convenience, I tend to divide safety into 3 major categories. There's a lot of overlap, but it's a way of looking at it. The first is technical safety. I do a lot of front-end engineering work, so I tend to get into this area quite a lot. This is where you can make major design changes without much cost. You start to look at technical issues like gas dispersion, smoke and gas dispersion, fire and blast analysis, the layout of emergency evacuation routes, and all the rest of it. The formal safety assessment part of a safety case is mostly to do with technical safety, or at least in the design phase of a project. By the time of the facility is in construction, it's a bit late to be making these kind of changes. We then move into process safety, which starts to kick in as you start commissioning and into startup and operations. Obviously very familiar to all of us, the 14 elements of OSHA's PSM or whatever, things like procedures, management of change, inspection programs, pre-startup safety reviews, that kind of thing. And finally into occupational safety, which is what most people think of when they hear the word safety, slips, falls, trips. Onshore, the big one is usually vehicle movements. One of our clients has a very good safety record, a major oil company. With one exception, they've had an awful lot of vehicle accidents. And the whole topic of behavior-based safety fits into this area here. Okay, next slide, please. I don't want to make a history lesson of this, but it's maybe worth spending a few seconds just looking at the background to safety cases and how we got here. I've not been able to find any kind of authoritative work on the history of safety cases, but it's probably been going now for about 60 years. The first industries to do them, although they didn't use the phrase safety case, was nuclear power and aviation, both civil and military. The first quantitative risk analysis, as far as I can establish, was done toward the end of the Second World War, and I'll touch on that a little bit later in the presentation. One of the important things to understand about safety cases, the phrase safety case is a little bit unusual. As Esther said, it's the case you make to show that you're safe. The analogy is if you do have an accident and you're in court, your attorneys will make a case to demonstrate that in spite of the accident you were operating safely, which is certainly coming out of this BP report. That we're okay because the other people who did it. So other industries use different phrases for what is essentially a safety case. Nuclear calls it safety analysis reports, and so on. Within the process industries, safety cases probably got their start after the Cervato accident. This was a chemical release in the 1980s. No one was injured, but it was a severe release and bad environmental damage. And out of it came what's called the SEMPISEMS Directive in the year 1986, which is sort of sponsored by the European Union. And they said that companies need to do safety reports, which is sort of the beginnings of safety cases. They started doing safety cases in the North Sea in the 1970s. But in reality, the Common Report, which came out of the Piper Alpha accident, and I'll talk about that in a bit, was the major driver for safety cases. Obviously, today we're talking about the process industries with a focus on offshore. But safety cases can be used or are used, and typically it's in those cases where you have a complex industry. It's not easy to understand what's going on, and where the consequences of an accident can be very severe. Obviously, nuclear and aviation fall into that, and equally offshore oil and gas. Next slide, please. Next. Features of a safety case. Like most process safety programs, the basic philosophy is those who create the risk must manage the risk. As Esther just pointed out, the regulators can't keep up with the technology. The only people who can are the people who actually run the facilities. A safety case is fundamentally non-prescriptive, which means it's performance-based. There's not always a requirement to do a quantitative risk analysis, but usually you do. Therefore, you measure risk or you calculate risk quantitatively using fault trees, event trees, and other things. And that puts you into the vector subject of acceptable risk and what level of risk is acceptable. And there's basically been a move away from that because it's so contentious. Obviously, what you really use risk analysis for is not so much for absolute risk as for risk ranking options. We've got 2 or 3 ways of reducing the risk, which is the best way to go. And the quantitative analysis can be very helpful. The duty holder, which is not always the owner. By the way, that's a trend that's really taking off in the North Sea. That as the platform production goes down, the major oil companies are basically selling their platforms to much smaller companies. And they're hiring other, essentially contractors to become what's the duty holder. And the duty holder is responsible for the safety case. Having written the safety case, of course, you have a safety case regime, and you have to perform to that standard, and you're going to get audited and reviewed against that standard. You're likely to have a series of safety cases. The one that most people think about is design. You could have a safety case for the construction phase. You could have a safety case for operations, and increasingly an interest in decommissioning and abandonment. I'm actually on a committee, an SPE, Society of Petroleum Engineers Committee. We're putting together a conference where we're looking at life cycle issues to do with safety and other things. And of course, the safety case is a living document. It has to be kept up to date. Next, please. And just closing out the history. In the United States, really, the event was Santa Barbara, 1969, a blowout. It was a seminal event. It was a huge rise in environmentalism at that time. The following year was the first Earth Day. OSHA was created a year or 2 later. It didn't lead to safety cases, but it led to a huge awareness of safety problems offshore. Piper will talk about it in a few minutes. That was unequivocally the event that matters. Even now, after all these years, there's a lot to learn from Piper. What happened offshore in Europe and later on in Australia, New Zealand, and Southeast Asia was a focus and a drive towards developing safety cases. Whereas in the United States, the focus, there was an equally strong response to Piper. But the focus was on developing safety and environmental management programs, which can't come under API RP75. Probably don't have time to discuss why the difference. It's very interesting why the 2 areas went their different ways. And I'm not going to say that either is better or worse. Obviously, people are looking at the SEMS thing and saying, how did Deepwater Horizon happen? Well, one reason it happened is it's not covered by SEMS because it's a drilling platform, not production. But last year, Montara, Northwest Australia, 2009, they blew out a well and burned down the platform. No one died, but it was a close dip. And that was a safety case regime. Next please. Onshore, we saw something similar. I'll skip this, but basically you see in the same time frame we have the development of process safety management and risk management onshore. Next. Piper. After the Piper Alpha accident, Lord Cullen put together an inquiry, and one of the speakers, one of his committee was a guy called Brian Appleton, who at that time was managing director of ICI Australia. Brian Appleton has a videotape of what we call lunch and learn of the Piper. It's absolutely fascinating. Piper was a platform in the North Sea, about 60 miles northeast of the northeast point of Scotland. They had an explosion on board which they think killed about 7 men, and it destroyed a compressor building, or compressor house. But for me, the fascinating thing about Piper is that although 7 men died in the first explosion, why did the final death total be 167? And why did we totally lose the platform? It's a fascinating study, as Piper. One of the anecdotal things that's coming out of Deepwater Horizon is that because of the lessons learned from Piper and things like it, the death toll on Deepwater was obviously 11 people, which is very serious. It may have been worse. That many of the safety things that have been implemented in the last 20 years maybe made Deepwater Horizon less serious than it might have been. Next. We don't have time to talk about the cause of Piper, but it was just a catastrophe. The fire sprinklers were badly corroded. Back up. The diver was in the water, so they turned off the firewater system. They got fair enough. They were scared if they turned on the firewater pumps, they would suck the diver into the suction. In fact, I've often observed that one of the causes of major accidents is that someone somewhere was trying to improve safety. The logout tagout system failed totally. Other platforms continued to pump oil into Piper even though it was burning, and so on and so on. Fundamentally, Piper was a total failure of the technical safety and process safety systems. And it led to a total reevaluation of how we manage safety offshore. Next. Next, please. Consequences of Piper, I'm keeping an eye on the clock. As I said earlier, in Europe, Australasia, Southeast Asia, we developed the safety case concept. In the US, more of a focus on API standards. But I think it's important not to draw a bright shining line between these two. For example, the safety cases in the North Sea draw heavily on RP14C, which Esther already described a little bit. And RP75, which is the controlling standard in the US, is very non-prescriptive. So I think there's probably more overlap than we sometimes realize. And as I said earlier, both have been both equally effective or ineffective. Next. The Cullen report. After Piper, in the British system, if you have a major accident like that, the inquiry is typically headed by a High Court judge. In this case, Lord Cullen was a High Court judge in Scottish High Court judge. In the US, it's a different system, but the analogy would be, imagine after Deepwater Horizon that the inquiry would be led by a Supreme Court justice from the state of Louisiana. It would be something like that. The Cullen report was extremely important, highly critical of many design and operating practices, and it strongly urged the offshore industry to really work on its safety cases. Even though safety cases had been in use before then, you can almost regard the Cullen report as being the real start of the safety case regime offshore. Next. And the Cullen report has become a sort of reference. It's the foundation document for lots of safety work. The quotation at the top is taken directly from the Cullen report. Primarily, the safety case is a matter of ensuring that every company produces a formal safety assessment to assure itself that its operations are safe. Let me unpack that and look at two parts of it. A company has to assure itself. Fundamentally, a safety case is not a regulatory thing. It's that you have to assure yourself that you have a safe operation. How you do it is up to you. And there's a tremendously important example of this. In the last 5-6 years, more than that, 10 years, as we know, we're getting to very deep water in the Gulf of Mexico, as much as 12,000 feet. The platforms are huge, costing between $1 and $2 billion. Companies can't afford to lose them. Those two pictures, Thunderbolts on the top, very nearly went down. They were very lucky to save it. That was in 2005. The one on the bottom is the Chevron's Typhoon platform. It's a TLP upside down. It's flipped. They never did try and get it back in service. So what's happened is companies have been doing is what in effect are safety cases in the Gulf of Mexico, but not calling them that. But the driver has been economic, not safety. The second quotation, part of the quotation I'd like to talk about is the phrase formal safety assessment. And that's a major part, it's probably 95% of the effort in a safety case goes into that formal safety assessment. Okay, next. Here's the definition of a safety case. There are various definitions floating around. This is the one that's probably as good as any. A safety case is a documented body of evidence that provides a demonstrable and valid argument that the system is adequately safe for a given application environment over its lifetime. It's documented. Everything you do has to be got into a safety case. That's why they tend to be so big. It's evidence. Essentially, you're making the evidence as if you're in a court of law. You're putting forward the evidence that you're safe. And you've got to demonstrate that you're safe. You've basically got to be ready to handle, if you like, a hostile attorney. The word adequately, of course, begs a lot of questions. What is adequate safety? You have to come up with some definition of adequate safety and figure it out. And then show you doing it. Application, that means that different facilities will have different safety cases. Obviously, drilling is different from production. Floating platform is different from a fixed platform, and so on. And it's a lifetime thing. As I said earlier, you may even have 3 or 4 safety cases. Right. The policy of safety cases. This is a notorious one. It's called the Nimrod safety case. Nimrod is a military airplane flown by the Royal Air Force and British Air Force. They had a fatal accident in Afghanistan a few years ago. The plane went down and 14 people on board died, all the crew. It was not hostile action, it was an accident. After the accident, they did an investigation. I said earlier that investigations are led by High Court justices. In this case, it was actually led by what's called the Queen's Counsel, which is like a very senior attorney called Haven Cave. And he was extremely critical. The Nimrod safety case was a lamentable job from start to finish. It was riddled with errors. Its production was a story of incompetence, complacency, and cynicism. And he named names. In fact, the only people who got out of this unscathed were the men who died. It was fatally undermined by a general malaise, a widespread assumption that Nimrod was safe anyway because it had flown safely for 30 years. And the task of drawing up the safety case became essentially a paperwork and check-the-box exercise. Next. Okay, again, I'm keeping an eye on the clock. How do you structure a safety case? Well, as we've said many times, it's up to you. This is an example. Safety cases I've looked at tend to have this, if you like, this table of contents. Executive summary and introduction, policies and so on, facility description, how you manage safety, the formal safety assessment, which is the bulk of it, and the audit and review process. Next. So the first part is, actually, I'll skip the summary. Policies and objectives. That's important. For example, I'm working on a project right now. We're at the front-end design of a very, very large platform in northwest Australia, offshore. And their objectives they have two that are very, very explicit. One is they want a totally smooth startup. They don't want any hitches in the startup. Secondly, they're very remote. So they have to be able to do everything themselves. They can't just pick up the phone and get spare parts. I understand that Western Australia is 6 times the size of Texas. There's no one there. So the company involved has to set its standards and its goals. Next. Next thing. Regulations. Obviously, wherever we are, we have lots and lots and lots of regulations from MMS or DOE or whatever they are, from the Coast Guard, from many other organizations. And we have standards that cannot be ignored, standards from API, from ASME, IEEE, and so on. The fact that you've written a safety case doesn't mean you ignore the regulations. But the safety case has to show how you complied with the regulations. It's not a sort of end, you can't do an end run around the regulations. The safety case should summarize the rules, show how they're being complied with, and how they're integrated into the overall system. This is very important for people who've done a lot of work offshore in American waters. Because actually, the preparation of a safety case for those people could be actually fairly simple. They've done all the work. It's just a matter of maybe of integrating it and coming up with a holistic document that shows how they've met the work. Standards, as I say, often referred to standards from API, ASME, and the others. Participation and involvement is critical to any safety program. Its preparation and implementation is a problem, or a potential problem, especially the formal safety assessment, because it often involves, it has always involved, very specialized people doing things like computational fluid dynamics, very, very tricky calculations for things like blast analysis, and frankly, no one can understand it apart from the specialists. And it's a serious management challenge is how to sort of integrate these specialist functions into the overall safety case so that the whole thing is comprehensible. Next, please. The facility description, in the interest of time, I'll just skip over this, but basically, the safety case requires you to have a complete facility description. It shouldn't be particularly difficult, but the philosophy is that someone reading on using the safety case, whether it's an employee or an auditor, doesn't have to go anywhere else to get information. It's all there. It's true that some of the information may be referenced, and you may physically have to go to a different place, but it's an integrated system. Next, please. The safety management system, earlier I said that there are sort of, I tend to look at safety in three areas: technical, process safety, and occupational. And the safety management system looks at all three. But the formal safety assessment is only a piece of the whole puzzle. You integrate it with the process safety, and you integrate that with your occupational safety, especially during the construction phase. And you have the management system. It's particularly important to think about the role of contractors and how you facilitate them. Next. Okay, the next section then of this presentation is the formal safety assessment. As we've said many times, what you put into the safety case is up to you. There's no single standard. But this is a fairly representative formal safety assessment. It's fairly typical of what you would see for a large platform. Each one of these, of course, is a huge topic. I mean, you could do probably a 1 hour webinar on some of these. You could probably do a 2-day webinar on some of these topics. All I can do is just quickly hit the headings and just say a few words about them. Project HSE plan is to do with safety on the project itself. In the early stages, that's not much of a particularly difficult because it's basically office-based. Most accidents are likely to occur when someone is driving. Safety and design philosophy is important. I've just finished one. I just finished it last week, where the client insisted that inherent safety percolate the whole project. And I spent quite a lot of time thinking that through and how we were going to make that work. And if anyone's interested, we'll talk about that afterwards. The assumptions register, which is something like a facility description, is assumptions that you made, for example, about weather and earthquakes and that kind of stuff. All have to be written down. Hazards register, we're all familiar with that. The hazards come out of HazOps and management to change in other places. We have to record them and manage them properly. Hazard identification, as with any facility, as you progress through the design, you do more and more hazard IDs and HazOps. A layout hazard review is extremely important, and I've broken it out as separate from the hazard identification. Platforms are extremely congested, and a layout hazard review is so important to safety. Formal safety assessment usually requires you to identify major accident events, probably should be major consequence events, like explosions and fires, the release of H2S, that kind of stuff. And safety critical elements are those safeguards that are critical to safety. That if you were to lose that safeguard, things would be really not in good shape. Explosion analysis obviously needs to be done, leads to the decisions about firewalls or whether or not you have plated decks and open decks, that kind of stuff. Gas and smoke dispersion analysis. Most of the men who died on Piper were due to smoke inhalation. It wasn't the fire or the explosion. That's an important subject. Non-hydrocarbon analysis. Most platforms don't have a lot in the way of non-hydrocarbons apart from H2S, but they will usually handle skips and drums of non-flammables. Material handling, very important. Over 40% of accidents on offshore platforms are caused by dropped objects. In other words, someone drops something from the crane. You can drop it on the deck. You can drop it onto the service boat that's standing nearby. And if it's a big object and you drop it overboard, that's even more serious. In 10,000 feet of water, by the time it reaches the seabed, it's moving very fast. Emergency evacuation. I don't know much about this Mariner event that occurred in that last week, but what we've heard already is that fortunately all the men on board escaped. They escaped by putting on life jackets and jumping on board. Evidently the lifeboat system just didn't work at all. Temporary refuge, where do people go while they wait for to be rescued? Emergency systems, survivability analysis, which again was a lesson from Piper. The emergency systems that just didn't work. The firewater never came on. Environmental analysis, a specialized topic. Noise analysis, possibly could go with human factors. Quantitative risk assessment, LR, well, I'll do in the next two slides. Human factors, fairly straightforward, is important. And the health assessment as distinct from safety. Next. Next, please. A quantitative risk assessment, as I understand it, it's not always a legal requirement. I believe that some Australian safety cases you do not have to do this, but typically people do. It's not controversial, debatable, because the objective values of risk are so difficult to defend. The data we use is typically of pretty poor quality, although the offshore industry has done quite a good job there with the ARESA database, and we overlook common causes. That little rocket on the bottom left, that's the V2 rocket. That was used by the Germans to bomb England in 1944. And they had a lot of problems with it. It would blow up on a pad or blow up in flight. And they started to think through the first concepts of fault trees and the rest of it in order to make that more reliable. The best use of quantitative risk assessment is for relative risk. How can we improve things, not what's the objective value. Next. Allah, given that you're doing quantification of risk and given that you have no prescriptive standards, you do need some method of saying we have gotten there. We've reached the level of risk which we're accepting. Most companies are used to the idea of 3 levels of risk. You'll see it in most risk matrices. Red means it's totally unacceptable. Yellow, orange means it's sort of marginal. And green means we can live with it. But risk is subjective. High consequence events are always less acceptable than low consequence events, even when the overall risk is actually the same. Certain types of life are worth more. It's always felt that the child is worth more than an older person and so on. There's all sorts of subjective and even moral issues here, which we can't get into. And what happened in 2005, the UK, United Kingdom Health and Safety Executive started to move away from Allah because it is so potentially, potentially controversial. Next. Okay, let's wrap up. Maintaining the safety case, not much to be said really. You obviously need to audit it, review it, and make sure, of course, that what you've said in the safety case will be done. Bridging documents are very important. And I'd be curious to know how bridging documents were handled with the Deepwater Horizon event, if there were any. Because when you get 2 or 3 companies involved, typically you've got a platform with drilling going on at the same time. You've got 2 or 3 large companies who may have their own safety cases. And how do you bridge them? How do you integrate them? And that's an interesting and difficult question. If a contractor has his own safety case. Next, this is the final slide. What's happening in the Gulf of Mexico, or probably that's a little parochial there, I should say, United States waters. We already have safety cases for drilling. The International Association of Drilling Contractors has a template. So I think the argument about whether we get safety cases for drilling is a little bit, the horse is out of the stable. Whether we get them for production, I simply don't know. As Steve said at the beginning, there's almost certainly going to be a lot of regulatory changes. But the BOE is being extremely quiet about what's going on. I think it's reasonable to expect we may get safety cases for production platforms, especially in deep water. But I don't know. Okay, I'll conclude. Thank you very much for listening to me. And I'll pass the ball back to, I don't know, Steve or Phil.
Ian, thank you very much. Appreciate the overview on safety cases. What we want to do is use some of that information and show how that integrates with practical approaches. And basically what we want to do is tie all these concepts together and identify where we want to go from here, especially in a very dynamic regulatory environment where things are likely to be changing over the next couple months, and I'll be talking more about that in a few minutes. But first, let me introduce Carlos Cheek. Carlos is a project engineer with Risk Management Professionals. He received his Bachelor of Science and Master of Science in Mechanical Engineering from the Rochester Institute of Technology. He's been working with us in process safety management to gain exposure to a huge spectrum of industries and processes, and he's been instrumental in finding new applications and implementing unique solutions for addressing risk associated with various types of facilities. He's familiar with and has been implementing a lot of programs associated with risk management programs, process safety management, and safety and environmental management programs, the SEMP and SEMS that was identified previously and which we'll be discussing more in a few minutes. And at that point, I think I'd like to turn it over to Carlos.
All right, thanks, Steve. I was going to briefly give you some examples of applications as far as safety cases go. And as we've discussed previously, they're in a lot of the different industries, such as military. In Europe, they have the Rail Safety Directorate, and the aircraft control software is actually regulated by DO 178B and their accomplishment summary. And also the nuclear industry, in the UK, they have the Nuclear Directorate, which requires safety cases, and obviously many countries around the world that we've talked about before as well. Some quick regulations that require safety cases. The UK has the Offshore Installations, or regulations for 2005. That's the recently updated. The Control of Major Accidents actually regulates UK onshore facilities. The Offshore Petroleum and Greenhouse Gas Storage regulations in Australia. The Norwegian Petroleum Directorate requires safety cases in the North Sea for Norway. And then just some general guidance documents that are used to guide your safety case. For instrumentation and electronics, they have the 61511 that you can see there, and also the Machinery Directive in Europe. Your safety case, actually implementing your safety case, as we've talked about so far, is largely made up of your safety management systems as well as your environmental considerations. So, and a large part of your safety management system is actually in your maintenance and your hazard analysis. So we'll be talking a little bit about those as well when I turn it back over to Steve. But potentially the most important aspect of any safety program at a facility is actually developing a culture of safety, so that operators and people on a day-to-day basis think of and operate in a culture of safety. Some particular difficulties with safety cases is that they have an approach of being a bolt-on system. And actually, you'll see facilities actually already constructed and built, and then they'll develop a safety case after and try to bolt it on to that facility. And then they have to retrofit each other, which is very timely and costly, and can often, cause a safety case to struggle. So it's important that the safety case and the facility itself are kind of designed and built together. So the safety case should be started in the design phases of the facility. It would really make the safety case much more profitable in the end. And to talk about, some of the implementation that we just discussed, I'm going to hand it back over to Steve. Thank you. Mm-hmm. Thank you. Mm-hmm.
Mike, okay? All right. Carlos, thank you very much. As I mentioned before, let's talk about sensible implementation of safety cases. I'd like to try to pull it all together, show how this fits into other regulatory frameworks. So no matter what's on the horizon or which way the regulatory winds may blow, you'll be covered and you'll know what path to take to properly protect employees, the environment, and also address any regulatory requirements that come up. What's always important is to keep your eyes on the prize, keep sight of your objectives. What I'd like to do is introduce you to one concept that you want to keep in mind as you're doing all these different regulatory programs or implementing safety cases. And that's focusing on key objectives with respect to balancing risk. As Ian mentioned before, basically what you're looking at is a whole variety of scenarios associated with things that might go wrong at an offshore facility. Some, if you're looking at the diagram, may be low likelihood and low consequence. That would be scenario one. As you look at other scenarios, some may be higher frequency, some may be higher consequences. Those are really the balancing points and the way to really look at weighting the importance of various scenarios and looking for potential weaknesses at your facility. Keeping in mind that balancing probability and consequences in the framework of risk is the way to look for weaknesses, address weaknesses, and identify if your operation is sufficiently safe or not. You'll notice some dashed lines on the risk diagram to the left of your screen. Those are basically lines of acceptable versus unacceptable risk. Unacceptable, obviously, is you're traveling to the right and up as you're increasing consequences and increasing frequency. Notice also that the curve tends to be a little bit distorted. As Ian mentioned just a few minutes ago, risk acceptability is subjective, and people tend to find higher consequences at lower frequencies less acceptable than things that affect only a very few people or have only a minimal impact on the environment. So even though the lines of technical risk may be constant, things tend to get weighted a little bit more depending on the individuals impacted or for higher consequence events. Now, it's also keep in mind, this is a little bit of a busy diagram, but the main thing that I'd like to emphasize for those of you who are seeing this in color is that the core activities in the center of all these ellipses represent the embodiment and most of the work that you're going to practically do, not only in preparing a safety management system and your safety cases, if it goes in that direction, but also in terms of day-to-day operations. What this diagram represents is I tried to illustrate the different elements that you'll see in lettering here right in the center of your screen, II for incident investigation, PHA for process hazard analysis, MI for mechanical integrity. Those are all things that are common to all these programs. And what I wanted to illustrate is the fact what's encompassed by process safety management, that's PSM, risk management programs, RMP, SEMS, safety and environmental management programs, and safety and environmental management systems, and also safety cases to illustrate the fact that there's a huge degree of overlap and a lot of the core elements that really represent the majority of your integrated effort over the life of the facility are common to all those, which really isn't a big surprise. You know, when it comes down to evaluating safety and also maintaining safety at your facility, key elements will prevent injury to workers, catastrophic injuries to workers. Those same key elements will also prevent environmental exposure and more disastrous consequences and significant risk levels. So the green area in the center, these are core parts of all these programs that represent most of your work. You'll notice the blue portion, records and documentation. There's a little bit of extra effort required for SEMS programs in terms of the elements that have been outlined. The light green area to the right, PSM, requires employee participation. The orange area, HA, hazard analysis, is a requirement of RMP. And then in the yellow area, you see those new elements that are required of a safety case. Facility description, various elements of the safety case. That includes formal safety assessment, ALARP assessments, and also fitness to operate. Key thing to get out of this is the overlap, and trying to unify the program is a great way to go. Also, there's each of the individual elements also may have a lot of overlap. This is a slide depicting a lot of the very common techniques that are used to analyze risk from a simple process hazard analysis that may include techniques that you're very familiar with, HAZOP, what if, fault tree analysis, and FMECA. LOPA, layer protection analysis, overlaps with that significantly because you're looking at a lot of the same scenarios. Safety integrity levels, a SIL assessment overlaps a lot with respect to layer protection analysis and also involves a lot of the key scenarios that you look at for PHA. Quantitative risk assessment, QRA, really encompasses all these items to take a more formalized, more quantitative look at these same kind of scenarios. So what do you get out of this? Whatever type of tool you're using is looking at the same kind of scenarios and making sure that they're unified, they work together, and avoiding looking at things twice and making what you do evaluate more complete is a great way to address these kind of programs. Now this slide looks at the hazard identification elements, the hazard assessment elements, that same concept of the looking for overlap, trying to minimize it, and synchronizing these different programs really works for all the different elements that we just looked at in the previous slide that are common to these safety management systems. So what kind of strategies do you recommend for something like that? This is a very complex regulatory environment, a very complex set of requirements, basically recognizing that broad spectrum of activities that are encompassed by safety management systems. That's a key thing. Understand the fact that there's significant overlap, how all these different pieces fit together. What else do you do? Find out what the requirements are and implement the required elements first. And then if there are certain things that aren't quite required but may be beneficial for the facility and protecting workers in the environment, those sort of things can be done and should be done. But if they're outside the regulatory framework, it's important that you identify that you're outside that framework and that you're doing this out of a diligent interest in worker safety and the environment. Also carefully document if you're exceeding these regulatory requirements. If there is an accident, the regulator is going to look at what you're doing, and if what you're doing is beyond regulatory requirements, they shouldn't be citing you for it if it's not totally complete. Also, integrate these activities and minimize duplication. Recognize there are similar objectives for all performance-based safety management system requirements. As Esther identified earlier, this is an evolutionary trend, and that there's one common objective in terms of minimizing risk. How that is manifested in these different regulatory programs is a little different, but the objectives are common, and many of the steps required to protect workers in the environment are the same. Again, look at these overlaps to minimize duplication. Work towards a unified program. We go to so many facilities and see different documents for process safety management, risk management programs, for offshore facilities that have onshore counterparts in the same business units. Sometimes you'll see a SEMP document and a PSM document. That's really unnecessary. A lot of the elements, the techniques you use are common, so why not have a unified program so that it's more robust and easier to manage. Also, start simple. If you're really starting with a blank sheet of paper or you don't have a lot of these things out there, go ahead and get started on the different elements and then weave these things into your program. If you've got bits and pieces of operating procedures, take what you've got as a starting point and start pulling into the program. Take a look at what you've got in terms of a gap analysis, and then as necessary start filling in those gaps and update and enhance the completeness of any of the existing analyses or regulatory elements. So with all these things out there, all these different requirements on the horizon, what should you be doing right now? Well, first of all, I think it's instructive to take a look at what's been going on. A lot of these programs, safety cases, Ian provided a history and background. Safety and environmental management programs, API recommended practice 75. These have been around for a while, and for most offshore facilities are in various stages of implementation. After the Deepwater Horizon event and the Macondo well release was a pivotal regulatory shift, or is a pivotal issue that may precipitate a regulatory shift for United States waters. There's been a restructuring of the MMS, various briefs to the President. There's been a moratorium and restrictions that have been put on drilling in deep waters, which led to a moratorium on May 30th. There's been a continuous reorganization of the MMS and restructuring of what's become BOEMRE, Bureau of Ocean Energy Management, Regulation and Enforcement. This is undergoing continuous change. And you probably have noticed that in recent months, there's been a lot of educational activities going on where BOEMRE is conducting public forums. Basically, there's a lot of different groups in Washington undergoing fact-finding activities in preparation for pulling those things together, using the results of these investigation activities, and putting forth possibly fundamental changes to the regulatory environment for offshore facilities. Also, there have been a lot of different ideas presented at these forums. The one in Houston on September 7th, DNV, which is a part of a regulatory body in the North Sea, and also they do consulting type activities. They provide a presentation on their vision for what the regulatory environment should look like in the United States. All these things are going to be brought together over the next few months. And in fact, there's some indication that maybe within the next 2 or 3 weeks to come up with at least proposed regulations as BOEMRE is restructuring. The target is this fall for coming up with some sort of rulemaking to build on the June 8th and June 18th directives that were put out by Washington. So what should you be doing right now? First of all, don't over-anticipate the regulatory requirements. There are a lot of things that are being proposed. Some of them aren't necessarily objective. A lot of people have agendas, political and technical and otherwise, for what's going on right now. I wouldn't undergo any major efforts until after you start seeing things in black and white, but laying the foundation for demonstrating compliance, knowing what you've got in your facility, and being prepared to move further in the direction of performance-based requirements like safety cases or safety management systems does make sense. You've obviously got direct recommendations and requirements from the June 8th and June 18th Department of Interior directives, and basically taking the things that are out there, safety cases, SEMS, doing a compliance audit at your facilities, finding out what gaps may exist, maybe a performance indicator audit, conducting these types of activities to know what the gaps may be so you can properly plan on addressing them expeditiously to make sure your facilities can continue operation, not only safety, but in adherence to any regulatory requirements, make a lot of sense. SEMP and SEMS specifically have 4 key elements that have been pushed forth as really key items that are higher priority than others. I'll show you those in a few seconds. And but plan on addressing all elements. So the key thing is don't jump through hoops. Find out what gaps you may have. If there are significant gaps that really represent a deviation from best practices, these are things you want to work on right now. And also make sure you got the resources in place for addressing all these regulatory requirements when they come up, especially if you've got significant gaps in your program. As I mentioned before, and we showed this slide earlier, there are a lot of key elements that everybody recognizes as part of a good safety management system. These things have been embodied in API Recommended Practice 75 and have been termed typically safety environmental management programs. The 4 that are in red are the ones that I was talking about as being higher priority. Regardless of what morphing may occur with the regulatory environment, there are certain things such as hazard analysis, management of change, operating procedures, and mechanical integrity that are common threads and considered very high priority elements. If there are gaps in your programs for these are things you want to be working on right away. Here I've repeated something that was in our last webinar with respect to what is encompassed by the June 8th and June 18th directives. Basically, they're focusing on operator training, procedures, certification of equipment, mechanical integrity programs, pretty much consistent with the sort of things that have been identified as your primary elements for SEMP and SEMS for some time. And of course, focused on blowout preventers. For the June 18th, again, more with respect to understanding the potential for damage at a well, and also things such as well integrity, cementing operations, etc. So keep in mind that you've got a broad spectrum in terms of where things might be going with respect to safety management systems, regulations, and guidelines. The most likely event is these performance-based requirements that have been adopted in other parts of the world. We'll see more representation with respect to where things are going in the United States. Somewhere in the SEMS and safety case regime is probably where things are going to likely to fall out. So it does make sense to plan and start moving in that direction. Now here's some good news. What I'd like to do is share with you the fact that many of your business units really have a lot of resources available. If you do have gaps in your program or you perceive some gaps, recognize that the bulk of these elements, we talked about the overlap before, a lot of these different elements are common to other loss prevention programs such as PSN and RMP, and especially for facilities that have onshore business units, you've already got technical expertise in your company, or you know where to get them from external sources such as consultants, and you've already got the infrastructure and expertise to implement safety management systems for offshore facilities fairly effectively. What I'd like to do, and this is updated a little bit from last time, is demonstrate that overlap and just leave you with this as a reference for when you're looking at compliance for all these different elements. We're not breaking any new ground here. A lot of these elements are common to these other programs, and this is just a handy reference chart for what has been out there with respect to SEMP and SEMS versus the other elements that are part of other safety management systems. So I hope what you got out of that is a recognition that there are some new things being proposed, but the bulk of it is consistent with best practices and other regulatory requirements that are out there, and even better, things that many companies have already been addressing in various bits and pieces. And a lot of this is a matter of integration, and as Ian mentioned, there are some new elements for safety cases if either as a company's self-interest in assuring and assessing safety for its own benefit, or from regulatory requirements, these other elements can get addressed and woven into a comprehensive program. Now, as part of our offshore facility process safety series, we intend to use our expertise and share with you a lot of the technologies that are out there and hopefully help you expeditiously comply with your various program elements that may be out there. One of the things that we've got scheduled for October 14th for our next webinar is really to take a closer look at some of these PHA technologies that are out there, HAZOP studies, layer protection analysis, and safety and integrity level assessment, and integrating all these things together. These are things that have often, I've seen people do these as separate items, and it can be very inefficient. What I'd like to identify is, although that's currently planned, there is a potential for some proposed regulations being put out over the next few weeks by BOEMRE, and should that occur, we're going to go ahead and change the topic for October 14th. The schedule will stay the same, but we may change the topic to either take a look at these new regulations, and also there's other types of audits out there on to look at performance indicators. We may also take a look at performance indicator audits and weave that in too. Also like to let you know, for those of you who have the ability to get to the West Coast easily, there's the Prevention First 2010 conference that's being sponsored by the California State Lands Commission. That's happening on October 19th and 20th in Long Beach, California. So we've got a lot of, in addition to everything that's going on with the aftermath of the Deepwater Horizon and the Macondo event and the Macondo well release, there's a lot of things that are happening in Washington, other information sessions that are available. And I'd encourage you to stay tuned to the changes in technology as they're occurring. For your benefit, I just put some references at the back. And also what I'd like to do is just spend a moment. This is actually one of our speakers, Ian Sutton, has put together a number of good technical references on process safety and risk management programs. And a recent book, Process Risk and Reliability Management, addresses a lot of these key elements that we've been talking about and are fundamental aspects of any safety management system. So what I'd like to do is open it up for questions. And as we mentioned before, questions can come about using your chat interface. If you'd like to be brought online with audio, just request that of our producer, Nicola Tromba, and she'll be glad to pull that together. And also, I've put over here email addresses in case you have some follow-up questions or need some information, as well as phone numbers for contacting any of the crew at Risk Management Professionals or Ian Sutton directly. So I'll open it up for questions. Also, are you able to put both video feeds from Houston and also from California on the screen? That'd probably be good. Cool. All right, it looks like we're in pretty good shape. If you do have some follow-up questions after this, you've got contact points. They're on the screen right now, and they're at the end of the presentation package that was emailed to all the participants last night, along with a little bit of background on all of the speakers. Thank you for attending, and we'll look forward to inviting you to our next webinar on October 14th. Thank you, guys.